Thank you, Josh, for the really great talks. Questions for Josh?
Thanks, Josh. When astronomers need to join with machine learning expert, who is doing the joining?
Yeah.
Basically, is it Astro going towards machine learning, or is it machine learning going towards Astro, in your opinion?
I think it's a really hard problem. It's a place where Stella Offner and I actually disagree. The problem is hitting a bullet with a bullet. Something that's publishable in AppJ and also publishable in some neural networks journal or ICML or whatever is hard. And to get them interested and us interested at the same time is really challenging, and it takes a lot of work. I don't have a great solution. I do think that if we want to solve these discovery problems, we aren't always going to need the most cutting edge thing or the thing that's most interesting. And so it does require a little bit of service from them. On the other hand, we're not coming empty-handed. I think it's a good thing to understand. Astronomy data is just catnip to computer scientists. It's not dangerous, right? It doesn't have any HIPAA or any of that stuff. Nobody cares if a galaxy gets poked or angry or something. It's huge, not ultra scale, but plenty big. And it's cool. And so I think what we might want to look at more is like an exchange where I say, okay, you have some weird thing you're interested in, which is not going to be helpful to me. Let me help you with the data. And you have some basic tools that I could learn to use better. And so if you have that kind of level exchange, we do have something to bring to the table, but it doesn't have to be that every project helps ML and helps Astro the same amount.
So there is a limitation for your model to obtain the spectrum from the image, regarding the resolution, like a low resolution image, it's possible to obtain the spectra also?
Yeah. So I think Peter actually showed, I could be wrong, or someone from your squad showed that, for instance, if you want to measure the redshift of a galaxy, if it's very high redshift, if it's pretty far away, you don't really gain much information from the blurry image of the galaxy. If there's only a few resolution elements across the galaxy, you don't gain much information. John will talk more about this tomorrow, but the result I skimmed over is that we are able to determine if something is low redshift versus high redshift, i.e. below redshift of say 0.01 versus high redshift based on the image. And so, yeah, it does matter. The amount of information does, you get more and more information, the higher and higher resolution you go. So there is some point of no return or of diminishing returns where you say, well, look, my basic information about a galaxy that might go in a row in a table, like its ellipticity, the orientation of that, the Cerseic index, whatever other, simple things, that does capture a lot of information that's important. And there is some turnover point where if you have enough resolution, you do better. These big space-based surveys are going to give you many more galaxies where you have a lot of resolution information. And so that's the thing I'm trying to prepare this community for is, it's not just going to be blobs everywhere. It's going to be weird things that have lots of information in them. And I don't think we have what will Rubin do with all of its redshift 0.2 galaxies? Hundreds and hundreds of millions and millions of them that have tons of information. Nothing so far.
Okay. Hi, Josh. Thanks for your talk. This is Stephanie. I'm with the mask over here.
Oh, hey, Stephanie.
Okay. So I really like how you mentioned earlier in your talk about the statement that the cosmos is very weakly modeled compared to our human experience.
Yep.
And then I was kind of stuck. I mean, I did listen to the rest of your talk afterwards, but I've just been thinking.
Yeah, that happens.
Because evolutionary trends is a lot of what we do in galaxy evolution, for example. Mm-hmm. But also with people, animals, there are also evolutionary trends. And I was like, is this inherently like a different kind of approach? Is it just because it's more difficult, like by nature, and it's messy?
I think it's because of competition. I think competition drives this this modality, we fit into these niches, right? Like literal niches with the, the Darwinian beaks, right? You're trying to get into like the little hole and the beak sizes change, blah, 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 blah. So I think essentially, galaxies don't have they don't have DNA, which then creates lineage, which then, they're not trying to optimize. It doesn't follow the same set of rules. There's a great, I mean, I've wrestled with the same question. Why is our lives so modal on Earth and so incredibly weakly modal in space? And I think that's basically it. I mean, products are the same way, right? Like you're using that laptop and he's using that laptop, and they're modal for the same reason, because they're under an evolutionary pressure, a market pressure. But this seems like a good philosophy conversation over drinks.
Thanks for the talk. What are your thoughts on the prospects of applying large language models in astronomy for hypothesis generation and end-to-end science?
You tempted me, or I tempted you. There was temptation. Hold on. Phenomena. Sorry, it's just like always playing in my head for some reason. Is that safe? Do I need to see a doctor? Okay, so self-supervised learning is basically a form of unsupervised learning, in which you're sort of removing pieces of the data, in this case text, and then trying to predict the text. That's how transformers work. So you've probably heard of GPT. The T is transformer, and I would love to sit and talk transformers at some point. But this is work by Jochuka, and she essentially used GPT-4, but in an adversarial way. It's a beautiful little paper. This was written by GPT-4. And to experts, this is like a pretty good thesis proposal. This is like, a student comes to you and they say this, and you say, we should keep talking. That's pretty interesting. Is it like a thesis? No. But did I think that 2023 was the year that we were going to get a model giving us a pretty cool idea for a thesis? No, I did not. I thought that was 2029. So I really woke up last year, and John and I have been working on, Michelle Namaka, and a number of other folks here actually at NORLab, on a project to work on using this text to build AI agents. And we're actually having a summer program this summer in collaboration with Johns Hopkins and the Center for Language and Speech Processing, which is going to be a sort of 6-week long-ish program to not only deploy some of these little chatbots that are designed to work with astronomy text, but also to learn what value they provide, to whom that value is provided, are they biased? Think really carefully about the services they provide. I think about providing services to the community because that's what Space Telescope does, and that's what I'm in charge of. And this is the kind of thing we might be doing. So thank you for that question. And I'm happy to talk more about LLMs and all the rest of that, the rest of the whole week.
Okay, maybe the last question.
Thanks, Josh. So to follow up on your statement about hypothesis generation a bit further, sounds like a good discussion prompt. I mean, so how would you write the discussion prompt, I guess, to make progress on that point?
Yeah, that's a good question. I think maybe the question that comes most close to me is, how do we connect up the knowledge that we have in our community with the knowledge that the machines have learned? So if you're using a machine, like, let's just assume that I'm not going to show, every image of LSST to, citizen scientists, that I'm going to need some machine learning approach. That machine learning approach is going to learn something about the manifold, okay, and about outliers, and it's going to know that. We need to somehow have an interface between that manifold of unknown things, and there's something interesting in there, and the knowledge base of the humans here. Because what Dahlia showed is I can find the 400 weirdest galaxies. I can choose my favorite 3 that show this cool E+A AGN thing and be like, okay, cool, I understand what's going on here. And if I hit it with KCWI, blah, 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 blah. And then there's 397 that have never been looked at or understood. They're not glitches. They're not errors. They're real things. And some of them are just like, that's 2 galaxies on top of each other. It's like not that interesting. But somewhere in there is something real interesting. And we don't know how to map what the machine has learned to what the community knows. And that mapping is, I think, critical for actually generating hypotheses, because the machines aren't going to generate them. Well, I guess it generated this one, but it's not going to generate it from data. So I hope that is vaguely useful.